G'day guys, we've got a calculus question today. Now the question says that the area of a triangle can be found by using the formula area is equal to half AB sine C. Using the incremental formula to determine the approximate change in the area of an equilateral triangle with each side of 10 centimeters when each side is then increased by 0.1 centimeter. Okay, so let's just figure out what we've been told here. We've got an equilateral triangle. So basically what that means is let's just make some notes that A is going to be equal to B is going to be equal to C, which is also I'm going to call equal to X. Now I'm going to represent the area of this triangle by A. And what else am I going to need? Oh, we've also been given the angle of one of the sides. Well, we've been given all of the interior angles because an equilateral triangle has an interior angles all equal to 60. And so from that, what we can say is that sine of the angle. Now, you guys, if you're hopefully aware of like your basic exact values for particular trigonometric ratios, we can say that the sine of 60 is square root 3 over 2. Now, what we're going to do is it's saying that we have to use the incremental formula. Now, when it says that, basically it's saying you can't just put this into your calculator and figure it out. You've got to use the incremental formula. And the incremental formula is as follows. It says, pertaining specifically to this, that the approximate change in the area of this triangle can be approximated by the rate of change of area with respect to the side length, evaluated at a particular side length, times by the then a small change in the side length. Now, this is for small changes in side length. The bigger the change in side length is, the less accurate our change in area approximation is going to be. Okay, so let's work out what the area of the triangle formula is going to look like, so then we can take the derivative of it. So we've got the area of a triangle equals AB sine C over 2. Now we know A is going to be equal to B, which is X. So this is going to be equal to X times X is X squared times by sine of 60 all divided by 2. Now sine of 60 we've just found out is square root 3 over 2. So what we can say now is we're going to rewrite this and say that the area of this triangle is going to be square root 3 over 4 x squared. Now the way I've done that is I've just multiplied the two denominators together and I put all of the constants as a coefficient of x squared. Cool. So from here, we can then just go straight into working out what the derivative of area is with respect to the side length. And what we're going to do is we're going to get the power and we're going to multiply it by this coefficient, square root 3 over 4, and we just get square root 3 over 2 because it's 2 times square root 3 over 4. So we're going to have square root 3 on 2x. That's our derivative. Okay, now to put it in the incremental formula. So, the change in area is going to be approximately equal to the square root of 3 over 2 times x when x is evaluated at 10. So this is going to be the square root of 3 over 2 times by 10, and then we have to multiply that by the change in the side length, which is 0.1. So sticking to that fractions theme that we've got going here, I'm going to just times this by 1 over 10. Cool. So what we can say is this is going to be approximately equal to 10 over 2 is 5. Times by a tenth, which is approximately equal to 5 over 10 is a half. The square root 3 over 2 centimeters squared. So this is obviously going to be associated with an increase in the area. Cool. Now, basically, guys, that's the, well, not basically, that is our approximate change in area right there. So this question was taken from last year's, in Western Australia, we call it mathematical methods. It's like a advanced introductory calculus course where you have geometry as well. So this is if you're going to do engineering or anything like that at university, this would be one of the maths courses that you would have to take in high school along with another specialist maths course. But, you know, this is a relatively complicated question for like a year 11 or a year 12, so someone who's 16 or 17 years old. But, you know, once you understand how the incremental formula works and sort of a few of the nuances with equilateral triangles, it's not too complicated. There's a few ways you can get tripped up, but a bit of in time, you know, and a bit of practice, those little potholes will be easily solved. So anyway, guys, I hope this video helped. If it did, you know, give it a thumbs up. If I could have any ideas, if you have any ideas, sorry, that for any videos that I can do answering questions on particular topics that you might have, just leave them in the comments section below. And, you know, throw me a like, subscribe to my channel, and until next time, guys, enjoy your maths.